This is the approach that I'm using to receive the data using the UART peripheral and the DMA feature. And so whenever there is no data going through the UART lines, this state is called the idle state, and we can trigger an interrupt once this event emerges. Also, there's another interrupt which we're interested in, which is triggered once we receive a byte via UART, and this is called the RX non-empty interrupt. And so imagine these are the lines which are being executed by the microcontroller, like this, and this is the UART interrupt. And so what we want to do basically, we want to call the interrupt once we received the first byte from the buffer that we're trying to read, like this, and then we want to disable the interrupt because we don't want to trigger it for every byte that we're receiving. We want to trigger it only once at the beginning, and then we are trying to continuously receive the data until the idle state is detected, and after we have received the whole buffer, we can enable the interrupt again. So I'll say here RX, like this, and then I'll say IRQ on. And obviously up here I should have written IRQ off, so I'll say OpenQ by DE. Then I'm using the Nucleo F756 ZG. It looks like this. And now enable the serial wire for debugging. Then go to RCC and enable the ceramic resonator. It is just the oscillator. And now you have to enable the UART peripheral. I've chosen PD8 and PD9, and go to connectivity and choose UART3. Now after that you have to enable the interrupt, so go to NVIC settings, enable the interrupt, now to go to the DMA settings and enable the RX request, generate the code, and then go to main.c. Let me declare two buffers. So the first buffer will be used only for receiving the data via UART, and the second one will be used for storing permanently the data so we can process it later on. And then I'll go to private variables. You have to enable the UART RX non-empty interrupt that I explained you before, like this. Now go to the interrupt file, so you can find it in the source file. Okay, scroll down a little, and now here you should check for the RX non-empty interrupt, whether it has been triggered or not. So I'll say here, like this, and then here I will disable the interrupt. So I'll say file and change the keyword enable to disable, like this. We should start receiving the data via DMA mode until we detect the idle state. So I'll say here HAL UART EX receive to idle DMA. This is the function that we're looking for. And then UART3, and then the UART buffer, and then the size, which is the maximum size. So this function will stop receiving until we have received 10 bytes or we detected the idle state. And now you should disable the half transfer complete interrupt because you don't want to mess up with that API. So I'll say here HAL DMA disable IT, because we want to trigger the callback after we have received the whole byte. So I'll say, this will take the address of the DMA handle, like this, and then the DMA HT, DMA interrupt HT, like this. Go to the drivers folder, then the HAL driver, then the include folder, and search for the UART header file, because here you should find the callback function, which will be called after we have received the whole buffer. So let me search a little. HAL UART EX RX event callback. This is the function that we are looking for. Just paste it above the in main function, and then let me do some changes over here, like this. And now I will simply copy the content of the UART buffer into the user buffer, and then the size of the received buffer. Declare the UART buffer as extern inside the interrupt file. So let me go above here and then declare it like this as extern. And now I have to enable the interrupt again, such that the microcontroller starts listening for the first byte of the next buffer. And let me debug in the program, and I'll open Hercules for sending the data to the microcontroller. So I'll select here serial, and then I'll close the connection. Now let me run it. I go into the live expressions tab, I'll select the user buffer, and I'll try to send something from the computer. So I'll say 1, 2, 3, 4, 5, 6. So I'll connect to it, I'll press send. As you can see, it says here 1, 2, 3, 4, 5, 6. In case you haven't thought about this problem, let me see what happens if you try, like if I try to send something which is bigger than the whole buffer size. So I'll say 1, 2, 3, like I don't know, 9, 8, 7, 6, 4, 5, 3, 2, 1, 0, 0, 1, like this. And let me see what happens. As you can see, we're not getting the right data. It wraps around and we're getting like 0, 1, 7, 6, 5, 4, 3, 2, 1, 0. So there's something wrong over here. And I will try to explain you the algorithm as best as I can, as well as I can. So we would have this buffer, which is the UART buffer. So I'll say here UART, like this. Excuse my bad writing. And then we would have the user buffer, like this. So I'll say user. Yeah, I guess it's right. By the way, if you want to get more access to me and learn more about embedded systems, I have created a free community on this, in which I'm hosting weekly webinars on various topics. Just check the link in the description. And let's say that we received a certain buffer. So I will just mark this out with yellow like this. And obviously we would have to copy this inside this user buffer like this. And now, once we receive the next buffer via the UART buffer, I will just overwrite this, like, let me choose another color, like pink. And let's say that this is the new content of the buffer, because the previous content will be erased and the UART buffer will be filled with the new data. What should we do now? Because the buffer size is bigger than the remaining size. I will split the UART buffer into two parts. So the first part, which is this one, oh, actually I have to choose another color. So I'll choose white. So this chunk from the first buffer, I will store it inside the remaining size. And then the next chunk of the buffer, I will store it at the beginning of the user buffer, such that it wraps around and then it will continue from the last position which will be over here like this. We have to simply add some code inside the callback. So let's say here I'll declare a static uint16t, which will take care of the current buffer position within the user buffer. So I'll say here uint16t current buff pos equal to 0, and then I'll say here if 10 minus current buffer position greater than or equal to size. I will simply copy the data inside the user buffer because the remaining size is bigger than the received size of the buffer from the UART. I'll just copy this, and now I'll just update the current buffer position. So I'll say here current buff pos equal to current buff pos plus size, and I will do this with modulus 10, such that if the current buffer position exceeds 10, which is the maximum number of elements, it will just go from the beginning again. And now let me implement the algorithm which will take care of when the received size is bigger than the remaining size. uint16t first chunk length equal to 10 minus current buffer position, and then uint16, like I will just try to copy inside the remaining size of the user buffer. So I'll say memcopy user buff plus, and then I'll say current buff pos, and then I say UART buff, and then the first chunk length, because we are copying the first chunk of the buffer, and then here I will just take care of the next chunk again. So I'll say here 16t sec chunk length, which is equal to actually size minus first chunk length. I hope you understand, guys. If you don't understand what I'm doing here, just ask in the comments. I will try to answer to all of the comments. I'll say memcopy. I will just copy out the second chunk of the received data. So I'll say here user buff, and then UART buff plus first chunk length, and then second chunk length, like this. And after that, I'll just have to update the current buffer position. So I'll say current buff position equal second chunk length, such that the current buffer position will be at the position of the last received byte, meaning over here, like this. And now I have to add something else, which I think you already saw. I have to add the current buffer position, such that we don't start copying, like pasting the content again from the beginning. So I'll say buff position over here. And now let me flash the program, and I'll open the Hercules terminal again. So I'll delete the window, and I'll send something completely random. So I'll say hello. Wait, it disappeared. So I'll say hello STM32. I'll run the program. I will open the live expressions tab. I will open the user buffer, and then I will try to send something. I'll say hello STM32. As you can see, it says here hello STM32. Now let me send something else related. Let's say embedded, like this, and it should be starting from the first position. As you can see, it says here embedded. And now let me send something else. So I'll say 1 2 3 4 5 6 7, like this. And as you can see, it continues from the last position. Here it says 1 2, and then it starts from the beginning. It says 3 4 5 6 7. So I hope you enjoyed this lesson.